Thank you for tuning in. This is a video from the 17th, 5 days ago, and I just aimed the camera up directly above our location, directly above the house, and it captured some interesting stuff. I just, wanted to do a short intro just to kind of explain a little bit. Um, I believe there were very large structures being drifted over our location, and I know there are a lot of people out there that don't think we have that capability, that we're not able to do that, but just do a little bit of basic research really is all it would take for you to look up drone technology, look into how many decades they've been researching, developing, and deploying like drone type of technology, and look at what they have available to us. As far as these little drones we see that people have cameras mounted on and they're flying them all up in the skies. I mean, the technology is there. We have the capability to be able to drift things up in the NEO, or the LEO, as some people refer to it as, the low Earth orbit or near Earth orbit, for a very long time, for extended periods of time, not just using some of the drone technologies that are out there, but also just by using helium. Okay. And they've been able to do this stuff for a while. And I believe they've been doing it in the extreme upper atmosphere for a very long time. And I believe they already have all of their little thermocouplers in place, that can draw energy off of the thermosphere. And then they, create a medium down here in low Earth orbit that can collect that energy and attempt to harness it and then redistribute it to, for humanitarian purposes in areas where there's disasters and people need immediate power, right? They could just beam it right down to you from space, right? This is what they've been working on for decades. Some of the first plans for space-based solar plants and wanting to put nuclear plants up in the upper atmosphere came out back in the mid 60s, late 60s, folks. So we're talking about over 6 decades of research and development into the technologies that would allow them to drift very large structures above our planet and redistribute energy that they are harnessing and collecting from the thermosphere and from the electromagnetosphere. They've been putting this stuff in place for a while. And I believe the whole thing with Elon Musk and all these Starlinks and all these launches that even the NROL is doing, the National Reconnaissance Office launch. I mean, they've been prepping for this for a very long time. And the fact that more people are seeing these things drifting over is kind of hopeful for me, because since I moved out here to Nevada and I have, a little bit of a different vantage point in the sky because I'm up a little bit higher, I'm a little bit closer to these things. I think that's probably why I've been seeing them, as much as I have for the last 5 years or so since I've been out here. And they've lowered their ceiling. They've lowered their dance floor, so to speak, their war floor. And when you look at the literature and all the information that's available to the public on the subject of space-based solar projects and space-based solar power, you'll see that it is a collaboration with all of the countries, all of the biggies. Okay. They're all working together to make all this space up here more conducive for them to conduct their war games and scenarios that they want to conduct. And all we can do is sit down here at ground level. And let me repeat that, sit down here at ground level. Okay. Because myself personally, I'm not buying into the whole flat earth thing and that the whole narrative and everything that's around with the flat earth. I believe we live on a non-rotating, stationary level plane. Okay. With territories out and around us, not up in here. And I do believe that they have researched and developed and deployed these technologies for space-based solar power long enough that they have confidence in lowering their dance floor and expanding their dance floor and lowering our ceiling. And that's why some of these things are being seen and more visible at this time. But anyway, this video just kind of shows some things drifting over. And there's several different clips that I could pull out and analyze and all of that, like I've done already. But I'm just going to go ahead and let it play forward. And then the audio file that you're going to hear is more information from the space-based solar project. Let me see if I can find that. Where is it? This one here. It's from the Space-Based Solar Power as an Opportunity for Strategic Security, published back in 2007. Keep that in mind, that it was 17 years ago when this feasibility study was done for space-based solar power. Do you really think that over the last 17 years they haven't researched and developed and deployed some of the stuff they're talking about? And there's so much that goes on in this capture. I just wanted to do a quick video to explain why I'm just putting in the visual as this capture of the sky directly above our location here in southern Nevada, and then the audio file of the space-based solar power, just in case there are still people out there, and I know that there are, that don't want to believe that we're capable of drifting these things over our heads. Myself personally, I'm not comfortable with them drifting these systems over our heads. I'm just not, because I know that it's going to create additional frequency pollution, and there are going to be people that are going to feel the effects of it, and there's going to be adverse effects. And those people are just going to be completely disregarded because they are going to move forward with this, whether we like it or not. It's very clear that they've had plenty of little meetings, and they've had their little committees, and they've had their international groups where they've got study groups where they've gotten together and talked to the most brilliant, brightest, most smartest people in the whole world about the topic. But not once have I heard them mention something about consulting with the public. In fact, any mention of the public and of the people has been, well, this is not going to be received well by the people. So here's what we need to do to make sure that, we can still follow through. They've even written up policies and legal jargon at their meetings when they've gotten together and conspired to get this done. And that's how I look at it. They have conspired behind closed doors in closed meetings on shaping policies, the legalities of being able to get away with something like this without being held responsible when things go bad, when Mother Nature pokes back. That is conspiring, folks. Plain and simple. And if that does not bother you and disturb you, then you're just not a human being living down here at ground level in reality. It should bother everyone that these people are getting together in these secret meetings and these committees and discussing ways that they can get around the legalities of our constitutional rights and our right to even oppose this type of stuff, because there's legal jargon in some of these publications where they actually discuss the scenario of having to deal with a public that does not want to accept this type of technology in our lives. They have developed a plan moving forward to deal with those people. And I think that is highly disturbing. By all means, if you want to have fun writing on things up in, space up above us, go ahead and have your fun doing stuff like that. But let's have a level of transparency and accountability for when things do go awry, for when things go awry, instead of just blaming every other thing in the book for some of these things happening, like climate change. Who's denying climate change, really? Seriously, that whole term of climate change deniers. Who's denying that the climate is changing? Nobody's denying that the climate is changing. I'm not denying that the climate is changing. I'm saying that the causes, what's influencing it, is a problem, because it's not natural. And when you continue to poke Mother Nature in the gut, she's going to respond in kind, if not kindlier. That is proven. And these people know it. That is a variable that they cannot control, and they know it. And the fact that they continue to move forward unchecked from the public is just disturbing, especially when I see stuff like this drifting over. I mean, how do I know this is not irradiating me? How do I know this didn't come over and create enough of pollution that started to begin a slow, long-term degradation of the biological system? How do I know that it can and it has the potential? Because I've read several studies on the topic of frequency pollution, and I've researched into it. The Body Electric was a pretty good source for that by Becker. And there's several other sources that cite, the effects that frequency pollution can have on a human being and on biological beings. And they've done studies on monkeys and mice and stuff like that for decades. They know it. That's why they had to get together in their groups and conspire and figure out ways that they can get around the legalities and having to be held accountable for those adverse effects that people feel. And too bad, so sad for those people, right? They're just going to have to deal with it, because whether we like it or not, we're going to move forward with all this type of technology that's going to create additional frequency pollution, right? And tell me you cannot see that for real. When you watch the video, I'm just going to go ahead and play the video. I'm going to put the full video. This is probably going to be pretty long, so it probably won't get fully watched, but whatever. I'm still putting the message out there. They're drifting things over our heads every day, and it's not going unnoticed by everyone. And it fascinates me to a certain level. But at the same time, like I said, because I'm repetitive, I have to say it again, I know it has adverse effects on us and our environment and animals in our environment. I know that it does. It's been proven. And I would be remiss if I did not do a video and say, quite simply, I do not consent.
SBSP offers a way to bypass much terrestrial electrical distribution infrastructure investment and to purchase energy from a reliable source at receiver stations that can be built by available domestic labor pools without significant adverse environmental effects, including greenhouse gas emissions. Finding: the SBSP study group found that one immediate application of space-based solar power would be to broadcast power directly to energy-deprived areas and to persons performing disaster relief, nation building, and other humanitarian missions often associated with the United Nations and related non-governmental organizations. Recommendation: the SBSP study group recommends that during subsequent phases of the SBSP feasibility study, opportunities for broad international partnerships with non-state and trans-state actors should be explored. In particular, cooperation with the United Nations and related organizations to employ SBSP in support of various humanitarian relief efforts support consistent with the UN Millennium Objectives must be assessed with the help of affiliated professionals. Finding: the SBSP study group found that SBSP is an idea that appears to generate significant interest and support across a broad variety of sectors. Compared to other ideas either for space exploration or alternative energy, space-based solar power is presently not a publicly well-known idea, in part because it has no organizational advocate within government, and has not received any substantial funding or public attention for a significant period of time. Nevertheless, DoD review team leaders were virtually overwhelmed by the interest in space-based solar power that they discovered. What began as a small email group became unmanageable as the social network and map of expertise expanded and word spread. To cope, study leaders were forced to move to an online collaborative group with nearly daily requests for new account access, ultimately growing to over 170 aerospace and policy experts all contributing pro bono. This group became so large, and the need to more closely examine certain questions so acute, that the group had to be split into 4 additional groups. As word spread and enthusiasm grew in the space advocacy community, study leaders were invited to further expand to an open weblog in collaboration with the Space Frontier Foundation. The amount of media interest was substantial. Activity was so intense that total email traffic for the study leads could be as high as 200 SBSP-related emails a day, and the sources of interest were very diverse. There was clear interest from potential military ground customers, the Army, Marines, and USAF security forces, and installations personnel, all of which have an interest in clean, low environmental impact energy sources, and especially sources that are agile without a long, vulnerable, and continuing logistics chain. There was clear interest from both traditional big aerospace and the entrepreneurial space community. Individuals from each of the major American aerospace companies participated and contributed. The subject was an agenda item for the Space Resources Roundtable, a dedicated industry group. Study leaders were made aware of significant and serious discussions between aerospace companies and several major energy and construction companies, both in and outside of United States. As the study progressed, the study team was invited to brief in various policy circles and think tanks, including the Marshall Institute, the Center for the Study of the Presidency, the Energy Consensus Group, the National Defense Industry Association, the Defense Science Board, the Department of Commerce's Office of Commercial Space, and the Office of Science and Technology Policy, OSTP. Interest in the idea was exceptionally strong in the space advocacy community, particularly in the Space Frontier Foundation, SFF, National Space Society, NSS, Space Development Steering Committee, and Aerospace Technology Working Group, ATWG, all of which hosted or participated in events related to this subject during the study period. There is reason to think that this interest may extend to the greater public. The most recent survey indicating public interest in SBSP was conducted in 2005 when respondents were asked where they prefer to see their space tax dollars spent. The most popular response was collecting energy from space, with support from 35% of those polled, twice the support for the second most popular response, planetary defense, 17%, and 3 times the support for the current space exploration goals of the Moon, 4%/Mars, 10%. How does one account for such significant interest? Perhaps it is because SBSP lies at the intersection of missionary and mercenary, appealing both to man's idealism and pragmatism, the United States' special mission in the world and her citizens' faith in business and technology. As an ambitious and optimistic project, it excites the imagination with its scale and grandeur, besting America's previous projects, and opening new frontiers. Such interest goes directly to the concerns of the Aerospace Commission, which stated, the aerospace industry has always been a reflection of the spirit of America. It has been, and continues to be, a sector of pioneers drawn to the challenge of new frontiers in science, air, space, and engineering. For this nation to maintain its present proud heritage and leadership in the global arena, we must remain dedicated to a strong and prosperous aerospace industry. A healthy and vigorous aerospace industry also holds a promise for the future, by kindling a passion within our youth that beckons them to reach for the stars and thereby assure our nation's destiny. 19. Focus areas. Science and technology. Whether lunar, LEO, or GEO-based, whether at radio or optical frequencies, space-based solar power is an immense and cross-disciplinary technological challenge, requiring contributions from many diverse disciplines. For a complete discussion, see Appendix A. A space solar power satellite is a huge construction, requiring expertise in large structures, control, and orbital dynamics. Its construction requires sophisticated techniques and careful logistics. Its power generation, be it solar dynamic, thermoelectric, or photovoltaic, requires expertise in solid-state electronics, optics, and thermodynamics. SPS power collection and distribution require electrical engineering, and the conversion of the electrical power generated in space into a coherent wireless power beam requires significant knowledge of the physics of electromagnetic wave propagation. Each of these challenges in turn also depends on competence in advanced material sciences. In all areas, there has been tremendous progress since the idea was first proposed by Dr. Peter Glaser in 1968, and some of the most impressive leaps have taken place since the Fresh Look study in the 1990s. In evaluating the long-term potential of SBSP, it is instructive to consider that global space utilities that are taken for granted today, such as Global Positioning System, GPS, and geostationary satellites, the Clark Belt, were once scoffed at and treated as mere science fiction until technology was able to catch up. Here, then, are the SNT findings of the interim SBSP study. Finding: the SBSP study group found that space-based solar power is a complex engineering challenge, but requires no fundamental scientific breakthroughs or new physics to become a reality. Space-based solar power is a complicated engineering project with substantial challenges and a complex trade space not unlike construction of a large modern aircraft, skyscraper, or hydroelectric dam, but does not appear to present any fundamental physical barriers or require scientific discoveries to work. While the study group believes the case for technical feasibility is very strong, this does not automatically imply economic viability and affordability. This requires even more stringent technical requirements. Finding: the SBSP study group found that significant progress in the underlying technologies has been made since previous government examination of this topic, and the direction and pace of progress continues to be positive and in many cases accelerating. Significant relevant advances have occurred in the areas of computational science, material science, photovoltaics, private and commercial space access, space maneuverability, power management, robotics, and many others. These advances have included A. Improvements in PV efficiency from about 10%, 1970s, to more than 40%, 2007. B. Increases in robotics capabilities from simple teleoperated manipulators in a few degrees of freedom, 1970s, to fully autonomous robotics with insect-class intelligence and 30100 degrees of freedom, 2007. C. Increases in the efficiency of solid-state devices from around 20%, 1970s, to as much as 70%, 90%, 2007. D. Improvements in materials for structures from simple aluminum, 1970s, to advanced composites including nanotechnology composites, 2007, and many other areas. Finding: the SBSP study group found that many different architecture/construction proposals have emerged since the original photovoltaic geostationary orbit concept was first proposed by Dr. Peter Glaser in 1968. Today, there are two major schools of thought regarding system placement: Earth orbit or lunar-based. Additionally, there are many who feel that the utilization of lunar resources to construct either moon-based or Earth orbit-based systems is a credible, evolutionary pathway for SBSP. Finally, the mechanism for capturing solar energy can be accomplished one of two primary ways: via photovoltaics, concentrator or thin film, or solar thermodynamic systems. Each of these architecture options has pros and cons, and assigning merit to one over the other is beyond the scope of this Phase O interim report. For a more detailed discussion regarding pertinent design trade questions, see Appendix A, SBSP Design Considerations and Trade-offs. Finding: the SBSP study group found that over a decade has elapsed since a systematic study took a fresh look and clearly studied the current status of component technologies. This results in a lack of precision of the true state-of-the-art in component technologies for integrated design trades required to build a roadmap for systematic risk reduction. The technical challenges associated with construction of a space solar power satellite are well understood and can be identified for systematic risk reduction and retirement. These include demonstration of power beaming at significant levels over significant distances, robotic and 21. Operator construction of very large space structures, high power/low mass in space solar power generation, management and storage, and ubiquitous space access and operations. Recommendation: the SBSP study group recommends that the United States should conduct a survey of state-of-the-art component technologies, identify major types of satellite designs that are feasible to build using known technology, and generate a roadmap to inform further decisions for rational retirement of risk for full-sized SBSP systems. Such an effort is likely to cost approximately $500,000 to $2 million. Finding: the SBSP study group found that over 2 decades have elapsed since contractor-led studies performed detailed and integrated system designs. Recommendation: the SBSP study group recommends that the United States should pay for at least 2 independent, but coordinated contractor studies of updated SBSP reference designs in the 110 GW range. Such an effort is likely to cost approximately $10 million. Finding: the SBSP study group found that retirement of the SBSP technical challenges begets other significant strategic benefits for exploration, commerce, and defense, that in and of themselves may justify a national program. At present, the United States has very limited capabilities to build large structures, very large apertures, or very high power systems in orbit. It has very limited in-space maneuver and operational capability, and very limited access to space. It cannot at present move large amounts of mass into Earth orbit. The United States correspondingly has extremely limited capabilities for in-space manufacturing and construction or in-situ space resource utilization. It has no capability for beamed power or propulsion. SBSP development would advance the state-of-the-art in all of the above competencies. The expertise gained in developing large structures for space-based solar power could allow entirely new technologies for applications such as image and real-time surface and airborne object tracking services, as well as high-bandwidth telecommunications, high-definition television and radio, and mobile broadcast services. It would enable entirely new architectures, such as power platforms that provide services to multiple payloads, autonomous self-constructing structures, or wireless cooperative formations. The Solar Electric Transfer Vehicles (SCTV), needed to lift the space solar power satellites out of low Earth orbit, and perhaps even form its components, would completely revolutionize our ability to move large payloads within the Earth-Moon system. The technology to beam power over long distances could lower application satellite weights and expand the envelope for Earth and space-based power beaming applications. A truly developed space-based solar power infrastructure would open up entirely new exploration and commercial possibilities, not only because of the access which will be discussed in this section on infrastructure, but because of the power available on orbit, which would enable concepts as diverse as comet/asteroid protection systems, deorbit of space debris, space-to-space power utilities, and beamed propulsion possibilities including far-term concepts as a true interstellar probe, such as Dr. Robert Forward's StarWest concept. Finding: the SBSP study group found that individual SBSP technologies are sufficiently mature to fly a basic proof-of-concept demonstration within 4-6 years and a substantial power demonstration as early as 2017-2020, though these are likely to cost between $5B-10B in total. This is a serious challenge for a capable agency with a transformational agenda. A proposed spiral demonstration project can be found in Appendix B. No government or private entity has ever completed a significant spaceborne demonstration, understandable to the public. To provide proof in principle and create strategic visibility for the concept, the study group did discover one European commercial consortium that was attempting to build a MW-class in-space demonstration within the next 5 years. While a series of experiments for specific component selection, maturation, and space qualification is also in order, a convincing in-space demonstration is required to mature this concept and catalyze actionable commercial interest and development. There are also critical concept unknowns that can only be uncovered by flying actual hardware. Recommendation. The SBSP study group recommends that the U.S. government should sponsor a formally funded, follow-on architecture study with industry and international partners that could lead to a competition for an orbital demonstration of the key underlying technologies and systems needed for an initial 550 m-week continuous SBSP system. The physics of microwave power transmission at expected frequencies, 2.45 to 5.8 GHz, require a very large transmitter, greater than 0.5 kilometers diameter at full scale, regardless of the amount of power transmitted, and this is a chief driver of system mass. Recommendation. The SBSP study group recommends that one minimum criterion for a meaningful demonstration must ensure it is not a throwaway system, and provides some significant leave-behind capability that is clearly on the path to a full system. Less expensive demos are possible, but may be counterproductive as they would not meet all of the required criteria. Finding. The SBSP study group found that the underlying technical challenges related to SBSP are identifiable and technical challenge reduction pathways can be described. DoD and other ongoing U.S. government and international R&D efforts are independently reducing SBSP technical barriers via S&T development for other goals. However, there is no single entity for identifying and tracking these independent developments for the sole purpose of SBSP applicability. Numerous technological advances are emerging for each of the technical challenges. Example, entrepreneurial private space access ventures, highly efficient concentrator photovoltaics, very low-weight thin-film photovoltaic systems, etc. Recommendation. The SBSP study group recommends that the U.S. government establish a formal activity for cataloging, monitoring, and engaging on major S&T developments which enable SBSP. Effort should begin with DoD and U.S. government activities, and eventually expand as appropriate to include all allied and other potential partner nations. Policy and legal. Space-based solar power is not a small project, but might be considered comparable in scale to the national railroads, highway system, or electrification project than the Manhattan or Apollo endeavors. However, unlike such purely national projects, this project also has components that are analogous to the development of the high-volume international civil aviation system. Such a large endeavor carries with it significant international and environmental implications, and so would require a corresponding amount of political will to realize its benefits. It is therefore important to consider three corresponding questions. First, does the fundamental concept of space-based solar power sufficiently address the defining strategic problems and interests of our time to interest a broad spectrum of leaders and policymakers both nationally and internationally? Second, is there a potential coalition of interested parties in the public and private sector? And third, does there appear to be a path toward an enabling legal and policy framework? Finding. The SBSP study group found that no outright policy or legal showstoppers exist to prevent the development of SBSP. Full-scale SBSP, however, will require a permissive international regime, and construction of this new regime is in every way a challenge nearly equal to the construction of the satellite itself. The interim review did not uncover any hard showstoppers in the international legal or regulatory regime. Many nations are actively studying space-based solar power. Canada, the UK, France, the European Space Agency, Japan, Russia, India, and China, as well as several equatorial nations have all expressed past or present interest in SBSP. International conferences such as the United Nations Connected Space 3 are continually held on the subject, and there is even a UN-affiliated non-governmental organization, the Sunset Energy Council, that is dedicated to promoting the study and development of SBSP. The International Union of Radio Science, URSI, has published at least one document supporting the concept, and a study of the subject by the International Telecommunications Union, ITU, is presently ongoing. There seems to be significant global interest in promoting the peaceful use of space, sustainable development, and carbon-neutral energy sources, indicating that perhaps an open avenue exists for the United States to exercise soft power via the development of SBSP. That there are no showstoppers should in no way imply that an adequate or supportive regime is in place. Such a regime must address liability, indemnity, licensing, tech transfer, frequency allocations, orbital slot assignment, assembly and parking orbits, and transit corridors. These will likely involve significant increases in space situational awareness, data sharing, space traffic control, and might include some significant similarities to the International Civil Aviation Organization's (ICAO) role for facilitating safe international air travel. Very likely the construction of a truly adequate regime will take as long as the satellite technology development itself, and so consideration must be given to beginning work on the construction of such a framework immediately. Recommendation. The complexity of negotiating any type of international legal and policy agreements necessary for the development of SBSP will require significant amounts of time, 5 to 10 years. The SBSP study group recommends that the policy and legal framework development should begin simultaneously with any science and technology development efforts to ensure that intangible issues do not delay employment of technology solutions. Finding, the SBSP study group found that although there was universal agreement that international cooperation was highly desirable and necessary, there was significant disagreement on what form the cooperation should take. There are multiple values to be balanced with respect to international cooperation. The various goods to be optimized include efficiency, speed of development, cost savings, existing alliances, new partnerships, general goodwill, American jobs, and business opportunities, cooperation, safety and assurance, commercial autonomy, and freedom of action. Adding more and new partners may increase goodwill, but add additional layers of approval and slow development. Starting with established alliances and shared values fulfills some expectations and violates others. The spectrum of participation ranges from beginning with a démarche before the UN General Assembly, to privately approaching America's closest allies, to arranging multinational corporate conferences. Many participants felt the International Space Station, ISS, overvalued cooperation for cooperation's sake, and took mutual dependency too far. Finding, the SBSP study group found in order to successfully address major world problems in energy, environmental and national security, the U.S. needs to identify and then reduce or eliminate all unnecessary barriers to effective international cooperation on, and private industry investment in, the development of SBSP. Regardless of the form of international cooperation, space-based solar power will require modification or special treatment under International Trafficking in Arms Regulations, ITAR. Partnerships between U.S. and foreign corporations are often much easier to create and implement than government-to-government level partnerships, and more effective when the purpose is fostering economically affordable goods and services. Application of the International Traffic Arms Regulations, ITAR, may constitute a major barrier to effective partnerships in SBSP and negatively impact national security. Right now, ITAR greatly restricts and complicates all space-related business, as it treats all launch and satellite technologies as arms. This has had the effect of causing America's competitors to develop ITAR-free products, and had a negative impact on our domestic space industries, which can no longer compete on level ground. Many participants in the feasibility study were very vocal that including satellite and launch technology in ITAR has had a counterproductive and detrimental effect on the U.S.'s national security and competitiveness, losing control and market share, and closing our eyes and ears to the innovations of the competition while selling ourselves on a national illusion of unassailable space superiority. Effective collaboration, even with allies on something of this level, could not take place effectively without some special consideration or